The variable is in the exponent, so we need a logarithm to help us out. Okay, but before you do that, you've got to get the base by itself first. So 5 is the base because that's the thing that has a power on top of it. So this 3 has to go. We got to get rid of that 3 so that we can get the base by itself. That's 3 times all that stuff. So the opposite would be to divide 3 from both sides. So we get 5 to the negative x over 4 equals 15 divided by 3 makes 5. And then you might be able to use common sense here. 5 to the negative x divided by 4 equals 5 to the first power. Well, then that must mean the powers must be the same. And sorry, that's not common sense, right? This is like you got to know all the rules of algebra, so that's not common. But these have to equal each other. Negative x over 4 has to equal 1, so x has to be negative 4. But if you want to know the full math way of doing it in case it doesn't come out perfect like that, what you want to do is take a logarithm of both sides. Because taking a logarithm of both sides keeps a balanced equation, and the logarithm allows us to use the exponent property of logarithms. That negative x over 4 comes down and multiplies. And now we've got an equation to solve for x. I can multiply both sides by 4. So that cancels out the 4 over here. This is 4 natural log 5. And then I'm still trying to get x by itself. So this is just a number. It's multiplying to x. So I'm going to undo that by dividing natural log 5 from both sides. And those perfectly cancel out, right? So we get negative x equals 4, or in other words, x equals negative 4.